Hello guys, I'm Anand. So today we will see how to do time series analysis for any historical data, and how to identify is there any trend or seasonality in the data. So let's start with the data. So we have to first download the data. So we will download this data from Edward Aquifer Edward Aquifer, and there is historical data for all these five sites, which are first one is Baxter Index well J17, then all these sites, but we're gonna do some data analysis, time series data analysis, and identifying the trends on this J17 and the Comal Spring and the San Marcos Spring. So here is some insight of this data here. This is the discharge per second. So we want the historical data to perform Mann Kendall test. So for doing time series analysis, we have to go through the trends. Like we have to identify what are the trends in there. So for that we have to run Mann Kendall test, and for identifying the data is stationary or non-stationary, we have to run the Dickey test. So for running these 2 days, we have to do something quality analysis with the data. So we have to identify the missing values, and is there any correlations between is there any auto correlation between in the time series. We have to identify that because there are some basic assumption and the condition to run the Mann Kendall test. So we have to do all these things with the data. So first of all, we'll download this J17 data, which is like almost 96 years data. Then we will download this Comal and San Marcos data. So J17 data is readily available in CSV format, but for Comal data we have to go click here, and we'll have to go here. So here in the tab separator, you will get the data. Here is the data period is 1927 to 2023. So this is almost 96 years data. So we will replicate we will plot this kind of graph, this kind of plot. So where the site is the same for every data, and the data is like a year versus daily discharge, cubic foot per meter. So here is the 6 month analysis, but we will do it for 96 years, so we can identify the trends better, and we can get the insight of this data better. So let's start with the in the R Studio. So from here I have this J17, but unfortunately I read the file in R Studio, but while doing this all the things, first we have to extract the begin and end date from the time series data. So I did that. I get in same format, but here let me show you. Okay, so here in the datex things, I'm getting some error that is showing me that must be a finite number. So this is here beginning to end, but here showing that and is should be finite number. I have tried every method to extract the date and time, date, begin and end date in RStudio. I tried every way to get this sequence, to make this sequence, but I failed. So due to time conflict, I have to move on with this. So I've done this analysis on Comal Spring data. So for the Comal Spring data, we will start with the libraries. We have to attach the required library with this R session. So I have attached this XTS, Zoo, T series, then Trend, and Kendall. So I told you earlier that there are some basic assumption and condition to perform Mann Kendall trend test. So the first is the observation are independent and identically distributed. So the data should be normally distributed, and the data should have been independent. It should not be dependent on any other perspective or any other elements. And data, and the second most basic assumption is condition is data does not have any correlation. So that's why we have to uh, do the autocorrelation things. So we can get that. So that's why we will do the autocorrelation test. I'm sorry. Here, yeah. So we will do it, and data should not have seasonal or periodic pattern, just like wavelength. Wavelength has periodic pattern, so it's not work on periodic data. So here I have did some set directory, then read the file, and I've checked for the missing values, and I drop all the missing values. Then I check for the summary. Let me show you the summary of the data. That is, see, I have 49 missing values. I have dropped it. Then this is the summary of this. There is mean, max, and all these things. What is the length of data set? And there's site, only one site. So this is discharge, mean, max, and minimum. So let's extract the begin and start date. Here I have extracted begin and start date. Then I make sequence. Then I create a Jew object. So here once more I check that is there any missing value, but I found 0, so that's why we good to go. Now we did is all these things. Do Jew object, then we create a zoom that merge the dummy data set time alone with the Jew object, which D means discharge. So here in this session we will interpolate the missing values. If there isn't any missing values, we will interpolate that thing to get the result, and we will plot this data into this. So you can see that we are getting this kind of plot here. So there is a trend going down. This is 60s. So in 60s we have droughts, so that's why it is going down. Then it is not giving any particular trends here. So let's check autocorrelation here. So for the autocorrelation thing, it is we have to do this. Let me show the summary first. So here is the summary again for this zoom object, d.zoom object, and we have to do the autocorrelation factor. Lag is 8. So every 8 year we have to do this. Every 8 year, lag is 8 year, and the p, you can see this p value is very small here. And now we will do there is less autocorrelation between in this time series. So we are good to go with the Mann Kendall. So for the Mann Kendall trend test is running here. Okay. So yeah, we got the tau is minus 0.0347, then two-sided p-value is 2.26, which is less than. So there is no trend in our data, and we will do augmented Dickey Fuller test again. So ADF, that is ADF, and we will do something that is augmented Dickey Fuller test, which we can determine that is the data is stationary or not. So here is a Dickey Fuller minus 5.78, which is less than 95% constant, and the p-value is 0.01, which is less than 0.05. That's why our data is stationary. So we are good to go. Then we can do same with the San Marcos also. So this is how we can analyze the time series data. So there is just two things. We can do more things to this also. We can do like precise thing also, but due to some time conflict, we have to. Also, I'm getting some error for the San Marcos, but I'm fixing this error. So I will do for San Marcos also. So this is how you can do Mann Kendall and the ADF test. So thank you.